here we list up what to do today. A fundamental lecture, 3D graphics and 3D Max design. And we're going to move on to the lab exercise, series of lab exercises, 1 through 5. It's not that hard to do today, even if you got some new features on 3D, especially rendering features as we planned. It's not that hard to do compared to last week, so I think you can finish up everything within the course hour. So all requirements listed up here. But as I told you before, we have some overlapped schedule. What I mean is simply say in the class hour, we will deal with some part of it, some beginner's level and some lab exercises. And next week, we're going to deal with some overlapped part which represents some theoretical background, what we have done last week, and some new features. And next week, we're going to deal with something else, some overlapped part next week, something like this. That means you have to keep focusing on what we have done in lab exercise and theoretical background lecture. So today's lecture going to deal with, again, some computer graphics issues, some lab exercises we have done last week, as well as some new features we're going to be dealing with next week. Okay, let's get back to the course material. 3D graphics theory. 3D graphics and user interface. You may know what is user interface, especially graphic user interface. But last week, we already did some 3D Studio Max without any specific experiences. But you can do something according to my instruction and course material because you know how to use Windows application. Even if it's very complicated, you can use it because there are some common factors, so-called graphical user interface in computer software. So this is the software we're going to deal with in this semester, 3D Studio Max Design 2014. When I was a college student, also I used 3D Studio, different version, because officially announced 3D Studio Max at SIGGRAPH 1995. When I was a college student, I used this one for 3D rendering and visualization. At the time, just 3D Studio, not Max or no design version. Anyway, this is a screenshot of 3D Studio Max. Looks too complicated to general users. General people got stunned or something surprised, and they don't have any ideas whenever they saw this interface, messy GUI interface. Because too complicated and too many buttons, too many options, they don't know what to do, usually. Let's talk about computer software interface. How to use your computer software. Without any specific idea or any specific background theory, you know how to use computers, especially some basic applications like this. Firstly, we use menu, clicking mouse, file and save file, open file, close file, export. You know what's menu, right? And you know how to use icons, so-called toolbars, the group of icons. For example, B usually means make a text font in bold characters. Underline, you know how to use HWP or MS Word, PowerPoint. Some general features, general icons, you can imagine what this icon means by align right, align center, something like that. So it's a kind of metaphor. Something reflects some features, characteristics, or functionality as a metaphor. And Microsoft Office has this kind of grouped icons, so-called ribbon interface. Ribbon interface developed by Microsoft. So if you click Insert, Page Layout, Reference, Review, View, you can find out amount of associated icons and buttons defined in that group so that you can do something else, just clicking and doing by using your mouse and keyboard. Typing your characters, words, clicking mouse, left click, right click, and drag and drop, and scrolling wheel. Keystroke means also keyboard stroke, like typing. So this is GUI, graphical user interface. But GUI is not the all the issue we have, even if our software mostly based on GUI. Firstly, simply say we have three different stages of graphical computer user interface: CLI, GUI, NUI. Actually, we say CLI, GUI, NUI. That's what they pronounce. CLI means command line interface. Actually, there are some different definition or different description, but as simplified here, I put this note like this. CLI means command line interface. For example, command prompt. GUI, much advanced one from this one. Icons, windows, buttons, menus, graphical user interface. Most of Windows application and Macintosh application has GUI. So let me show you one example of CLI. If you click Start button and type CMD, black background with white fonts, that is kind of conventional Microsoft DOS interface. If you type CLS, clear screen. If I type dir, directory will be displayed. If you type CLS again, something like this. If you type ipconfig /all, the computer's IP address assigned to every Internet Protocol device in this laptop gonna be displayed because I typed all with command ipconfig. So this is something conventional and old interface. What if you type Explorer? What if you type Explorer? If I return Explorer, Windows Explorer going to be executed because that Explorer is a kind of command executed in this command line. Okay, just let me turn off. So what is NUI? Natural User Interface. Do you use NUI? You already use NUI every day. Probably right now, somebody will check Facebook. Or you living in Facebook. So even in classroom, right? You touch your screen, smartphone. Take a look at this one. Screen touch, motion recognition, and voice recognition. All these are natural user interface. You already use in your daily life using your smartphone. Clicking Facebook or clicking KakaoTalk, that is touch interface. And you type some text by touch interface. If you use Siri or some voice command line application, you already use voice. How about motion? When you do some game, your motion or your location or gyroscope detects your motion in your game or some specific software. So we already use NUI every day, probably much more than GUI. So general software we use today located this area, NUI and GUI. Actually, when I was a college student, at that time, MS-DOS was common and Windows early version of Windows just released. So I know this kind of interface at the time, but nowadays no one knows, and no need to know this. But this is general software. But how about this? General computer graphics software. Actually, you can draw something by touch screen for fun, not for CAD, not for design. That's just for fun, right? So we don't have any NUI so far, just GUI and some partial CLI, because in AutoCAD you type TL spacebar so that you can run trim command. The more command line you use, your CAD capability getting better. That's the reality. Because what? Efficiency and precision. You must type 100 millimeter rather than dragging 100 millimeter. You cannot drag 100 millimeter by mouse. You cannot, never, ever. But you can type 1,200 millimeter exactly. And then AutoCAD will generate 1,200 millimeter line. That's precision. Precisely drawn lines and radius 1 meter diameter or something else by AutoCAD or even other software. SketchUp, you can type something. You have to type some command, at least dimension. Nothing can be done only by mouse in computer graphics for design. But for fun, you can do by touch screen. You can draw your face, some text, whatever, but not actually design purpose. Here, design, the term design means building design, not graphical design or game design, okay? So in terms of building design, interior architecture design, we need precision and efficiency. So that is why we need to type command line. Just simply think about there is only no command line in AutoCAD, only toolbars are there. So you have to click trim, line, rectangle, anytime. Just clicking, and type, clicking, type. But if you have command line, you can save your time. Just simply type TL, L, E, O for offset, and so on. So but in reality, ideal interface for 3D modeling is NUI, actually. Simply think about you have kind of new interface. This is new interface. You click and draw some mountain like this, and computer generates mountain. And if you cut something, the geometry, that shape gonna be cut according to your motion. And you can rotate it. And if you see this is too thick, you can get it shrinking by your hand, by your magic wand, whatever. You can see in 3D, in tangible way. So that is ideal interface for 3D modeling. But actually there are some more things. How to model this room in 3D? You can measure the distance from here to there, and the height, and draw it by AutoCAD or 3D Max, SketchUp, easily sometimes. But what if you can scan it using 3D laser scan? Actually, this morning we did it for third-year students, and we got some 3D point cloud model for first floor of this building lobby. I'll show you it later for your information. But anyway, 3D laser scan is kind of easiest way to get the geometry of this room or this building. Very precise and fast. How about image processing? Just taking pictures, and then some specific graphic software will generate 3D model of this room without any additional tasks. Something beyond keyboard and mouse. I told you, tangible devices, manipulating by your hand, and it's going to be created in 3D real world. And sometimes you can type height 3 meter, width is 5 meters, but you can manipulate by hand in 3D. But as I showed you before, most 3D graphics tools use conventional manner, like this, handling 3D objects on 2D screen. Your monitor looks 3D because you can rotate and navigating or zooming in and out. But anyway, it's 2D. It has only X and Y coordinate system. But mathematically and conceptually, your model has Z-axis. That is why you can rotate it. But anyway, that is 2D. But your objects in your brain is 3D. That's a huge gap between those two different objects. Something displayed on your screen is 2D at that moment, but that object in reality in your brain is real 3D. So there is a real big problem manipulating, handling 3D objects on 2D screen. That makes all the problem. And too complicated 3D modeling. 3D box shape, 3D L-shape corridor, or 3D sphere. They are very simple to imagine. But what if some organic shape in 3D? Organic shape building, how to find the way from here to there. In human brain, even if human brain has very high intellectual property, we have intellectual quality. Anyway, it's not possible to imagine and draw everything for any geometry. Too complicated. Too complex options, too many functions in GUI interface. A lot of limitations. The gap between those two, real interface and ideal interface, this gap makes it hard to get 3D graphics. That is why you cannot learn 3D Studio Max or Rhino easily by yourself. Let me introduce some another different type of method, 3D laser scanning, something like this morning. In US dollar, 220,000 US dollar value this morning. The company from Leica, they brought this device for our department and scanned first floor and this room. And I got 2 files in point cloud, and we'll show you later for your information. Anyway, this valued device can scan by laser, something like this. And this is some kind of point cloud output file. Millions, even billions of points defined like this, with colors, sometimes some image-based things. And this kind of series of points can be easily turned into polylines, surface, sometimes some solid objects using different software. And then you can get precisely generated existing building. What if you want to remodel that building interior? You need CAD model, but you don't need to build or some drafting using AutoCAD again. Just simply scan it, and then you can acquire this kind of files. That's one method, and this is kind of example I would like to share with you. The first video I would like to show you is kind of ad from the Faro laser scanner brand. This one, probably some of you encountered what we have done this morning. Something like this device. This ad video will show you what to do and how to do, how it works. And second one is my example. Let me show you this video. Let's take a look at this video first. This video will show you what is a laser scanner and how it works, something like that.
Taking the world from 2D to 3D, Faro is a global technology company that develops portable 3D measurement and imaging solutions. Faro's commitment extends well beyond product performance and constant innovation. With Faro, you have 3D measurement peace of mind. The Faro Laser Scanner Focus 3D is a high-speed 3D scanner for the detailed measurement and documentation of large objects, spaces and buildings. With a range of up to 120 meters, the Focus 3D creates photorealistic, three-dimensional images of reality. Thanks to its intuitive control concept with a touchscreen display, it's as easy to operate as a digital camera. The rotating laser of the scanner touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object and, together with the device's 2 rotation angle data, determines the coordinates in space. Several million of these 3D coordinates result in a complete 3-dimensional impression of its surroundings. Color scans are produced with the help of the integrated digital camera. The scan data is saved on the internal SD card, making it very user-friendly to transfer the data to a computer. Faro's Scene software automatically combines individual scans with the aid of integrated sensors in the Focus 3D, such as dual-axis compensator, height sensor and compass, to create a cohesive point cloud.
The building industry is primarily developing towards the renovation of existing buildings, for which plans and drawings need to be prepared. For this, laser scanning is the perfect tool.
Data acquisition by means of 3D laser scanning is faster and more reliable than conventional documentation methods. Whether for 3-dimensional building documentation, monument preservation or forensic crime scene documentation, thanks to its simple operation and compact design, the Laser Scanner Focus 3D is ideally suited for a variety of applications. Reichenbach Architects in Hanover offers scanning services aided by professional hardware and software supplied by Faro. As a result of the innovative possibilities of 3D laser scanning, the market is expected to grow enormously in the future.
3D-Laserscanning der Markt in Zukunft enorm wachsen wird.
At Faro, our focus is on simplifying our customers' work with tools like the laser scanner that empower them to obtain data more quickly, easily, and with less cost than ever before. Today, more than 10,000 customers worldwide trust and work successfully with various Faro solutions, making Faro the leading 3-dimensional measurement and imaging company.
Okay, let me show you a real example. When I was in Autodesk San Francisco, some movable device attached to the 3D laser scan acquire this kind of image. Let's take a look at. Actually, it looks moving around, but no need to move, because acquiring the 3D cloud point clouds like this, this is university, college building, California College of Arts at San Francisco. They get this 3D and take some working path for getting and visualizing this kind of image according to its 3D point clouds. Actually, this is not that good quality point clouds, just example and visualization purpose. I show you this. For your information, let me show you that our building example we took today here. Okay, this Autodesk recap software will import the first floor points cloud file, 13% complete. Millions of points, and to visualize this project so that you can see what we take using that 3D laser scan. Some of you are here. This is just for your information. Let me visualize what it is and how to open and handle this kind of file, just for your information without any detailed information. We're going to deal with that later on. The point cloud file has XYZ coordinate system as well as its RGB color data and some distance data, very simplified geometric data for each point. And then this one will generate something like this. Okay. Actually, this is the main lobby, and this is actually some part of engineering one building and some trees, exterior. And let's take a look at interior of this building. Some people passing by, so they got this kind of picture. This is main entrance. And the two guys standing here intentionally for taking that picture. Okay. This is a 3D point cloud laser scan. This is a corridor and the pathway to upstairs and two elevators and some area. The ceiling structure, two guys standing over there. Actually, this software doesn't represent the color very well, but anyway, you can turn here to there. This is kind of partially acquired image. We need to take more 3D scan so that there should be no kind of dark area, such as behind this kind of structure, so that you can see entire structure. Okay, there's a tree plant and the main entrance looking in front of the main door, something like this. Actually, these are all point clouds, but what if you have some 3D model converted from this one? No need to draw or make some detailed 3D model. This is kind of quick overview in laser scanning. This is one option, but it's too expensive and it's actually not available to public so far, something specialized purpose. But in the future, the device is going to be really cheaper and powerful. Even you can handle it like this. You can scan it by your hand easily so that you can acquire 3D geometry without any errors. This is kind of something cutting edge, but we are using this kind of technologies. But even some more things in 3D modeling, something advanced, cutting edge things. iSphere, there is a 3D mouse, tangible, touchable objects. You can manipulate this one so that you can make your own 3D objects. Push-pull by hand, by your hand power. Cave, you can get that goggle using that magic wand tool. You can draw some 3D objects. 3D bricks, that looks like a brick, but if you stack it over or moving, turning around, you can manipulate 3D geometry. Paddle, also similar to the 3D bricks or some other interface. You can drag and drop some objects like this in 3D screen, 3D objects. So something beyond keyboard and mouse, new interface. There are several things to do. But in reality, we're not going to use that kind of advanced tools, we will use keyboard and mouse in 3D Max or some other similar 3D software tool. So actual reason is here. Why 3D graphics is too hard to learn. Do you know these? Ray tracing, bump mapping, Bezier curve, control points, segments, sweeping, lathing, knowing about camera and lenses, what is focal distance, what's aperture, what's exposure value, and so on. All these are kind of interrelated and something from different domain, but they are all about 3D graphics and rendering and modeling. So we have to understand what are these, okay? So that 3D model and 3D visualization tool without any complicated and iterative ways. Without understanding what are these, learning 3D software is equivalent to memorizing the sequence, the order of clicking buttons among hundreds of icons in a messy GUI interface. For example, if you buy a 3D Max book and follow by step 1, step 2, step 3, step 4, what if newer version of same software released, some interface changed? You cannot do anything in that case. Just your self-teaching for that software was just couple of months, at least, just 1 year. If you memorize the sequence of clicking buttons without any understanding for these. But what if you understood what to do and how it works? Remain thing is just accustomed to that new user interface. How this button or what is bump mapping icon or what is displacement functionality without any detailed icons or some messy GUI interface issues. You're going to be free from interface issues if you understood what you have to do or what you are doing. So if you understand the logic rather than the order of clicking buttons, you can learn any complicated modern 3D modeling and rendering software such as Rhino, Maya, Blender, Digital Project, Revit, as well as 3D Max, what we have to take care of this semester. Okay? Simply say, you should know behind technologies and fundamental theory background. Okay? Let's take a look at 3D geometric modeling. Here I list up some geometry subcomponents for making 3D objects. Vertices, in other words, points, and edges, in other words, lines, and faces, and their combination will generate polygons. Polygons make surfaces. At the end, this one gonna be one object. In this case, that is a box object. This box object has several subcomponents like this. So modeling 3D objects is very simply say, firstly creating an object and modify it, and iterative. Make, modify, delete, update, kind of iterative work. It's very hard to do and very time-consuming, tedious work. Modification also very hard to do, modifying geometry's subcomponents, because you have to deal with vertices and edges for manipulating the shape of this one. There is no way command, okay, blend your shape with sphere. There is no such command. You have to select edges or vertices and rotate or scale or do something in this level, in this sub-geometry level. That is why it's not that easy. 3D modification by 2D geometry. That's reality. This is 3D Max editable poly interface. There are vertex, edge, border, polygon, element mode. So each subcomponent you can control. We're going to deal with this one next week in editable poly modification in 3D Max. For manipulating that box shape, you have to control vertices, edges, polygons, or simply use modifiers or some other advanced tools. That's how 3D graphics software works. Okay, this is fundamental geometric edits. Let me introduce some generic ways of creating 3D geometry. In other words, modeling, how to model geometry. The first way, actually it's not first. Quick question. Do you know how many ways we can create 3D objects? In terms of creating 3D objects, classification, how many different types of ways? How many ways to create 3D objects in general approach? What? Not 200 or 3,000? Just 2 or 3? 2,000? How about 2 billions? No, your answer is close to the correct answer. I mean, just 5 or 6 in the world. If you invent a 7th way, the new way, your work going to be published in the journal, and you're going to be very famous, and you got amount of money, I think. Okay, before introducing such method, 4, 5, 6, I'm not sure, some of well-known ways, let me introduce the first one. The first one numbered 0 because that is kind of predefined elements, predefined objects. Take a look at this one: cylinder, donut, plane, box, something else. All these are primitives defined in 3D Max or even other general 3D software. Interesting thing is this teapot is one of the primitives defined in 3D Max. This is kind of legendary Utah teapot developed by Martin Newell. When Martin Newell had been working in computer graphics, he determined to model this teapot because when he was in this area, he saw the teapot surrounding him, probably on the desk, and he decided to model this one by computational manner, probably 70s, 60s, I'm not sure. And he made it. And that is why the button which has this teapot is render button in 3D Max. Kind of legendary Utah teapot. That's a real teapot, exactly same to that object. Anyway, there is primitives, and there are several types of primitives. Basically, you can create this kind of primitive without any complicated work. You can simply generate those primitives, and you can modify it using modifiers or editable poly, whatever. And you can totally change the shape, geometry of those primitives. So there are standard primitives, extended primitives, and bunch of modifiers for manipulating the shape of this one. Today we're going to deal with some of these examples. Take a look at this example. There is only one single plane and 3 mirror balls and 1 teapot, and Autodesk material assigned, ceramic and chrome and wooden floor, and 3 lights, 1 yellow color lights and 2 white color lights, photometric lights, and mentally rendered. So you can create this kind of a little bit photorealistic rendering image. This one shows this is not a picture. It's not possible, only available in this kind of computer graphics. So anyway, this kind of rendering is very easy to do, what you have learned last week so far in this kind of system, not that time consuming. Okay, let's take a look at the first way for creating 3D objects. Very few ways, 5, 6 ways I introduce you. I need to bring your attention to the rest of lecture. Okay? Okay, let's keep moving on. Creating 3D objects. We saw what are primitives. Primitives defined in 3D Max. You can create plane, box, teapot, and so on. What others? How to make 3D objects? The first thing is, very conventional and well-known way is extrusion. You know extrude in AutoCAD. Draw XYZ plane, 2D shape, and extrude it Z direction so that this one gonna get 3D shape. In 3D Max, you can draw 2D polylines in any shape, 2D, and make a thickness so that this one gonna get 3D objects. This is first way, extrusion, to make 3D objects. What is the second way? Lathing, revolving a surface. You can draw a surface, half surface, something looking like this, and revolving it so that you can create this kind of 3D shape. This is 2D section profile, revolve to create 3D objects. In reality, you need to design in this way a lot. For example, creating a column, very specialized column, or creating a vase, cup, anything else by revolving. Lathing is the term used in 3D Studio Max. In general term is revolving, okay? The third one is sweeping. Actually, this is very important thing because you can create any kind of 3D complex object using this algorithm, this method. You need two definitions. First one, section profile definition. Section means section, you know what it is. Section profile in 2D, that is the first one. Second one is the path, According to this path, this section profile gonna be turning along that path. So here is a section profile and the 2D path. This one will be generate this kind of shape. That is sweeping. That's general term. Actually, in 3D Max, some different modifier name. But anyway, the fundamental name for this is sweeping. What others? First one, skinning, kind of morphing. Star, circle, rectangle. Kind of morphing object will generate this kind of 3D. 2 or even 3, even more section profile will generate this kind of 3D shape. Similar to extrude, but different shape extruded. That is skinning and Boolean operation, constructive structure geometry, CSG, I'm not sure, but simply take a look at this geometry. Looks very complicated, but take a look at the algorithm. Union means plus, so cylinder plus vertical cylinder makes this kind of plus shape, and another axis cylinder will generate this shape. And this is intersection. Intersection between sphere, box will generate this kind of image. Simply this A minus B, this one minus B will generate this one as a final. So this is kind of Boolean operation. You know some Boolean operation defined in SketchUp. There is a box and cube, you can get A minus B or A plus B, something like that. So fourth, fifth, where is sixth method? No one knows. You can invent it. Additionally, I would like to introduce you reuse of 2D geometry. This is simplified 2D AutoCAD file. When you design your floor plan, usually we get this kind of 2D geometry. And then we can import it to the 3D Max with properly generated layer information. Turn on and off, and select them and extrude it so that you can generate walls, bottom slab, windows, and so on. This is fundamental way, but you can take some advantages from using AEC extended objects named wall, windows, stair, and so on. We're going to deal with this part later because this is actually the most important thing for the one who's dealing with building design, like us, interior architecture design. So usually we design some flat plan-based, vertically extruded walls, windows, attached doors, and so on, for making orthogonal shapes, buildings. So we're going to deal with this part in the middle of this semester. Anyway, it's based upon AutoCAD file. But in the meantime, actually, you don't need to draw this kind of plan in AutoCAD. You can directly generate this kind of floor plan in 3D Max. 3D Max experts, they don't use AutoCAD or some other software. They do everything in 3D Max. This is an example. AutoCAD floor plan imported and extruded objects and defined some fundamental objects, even this kind of foliage, trees in 3D Max. Without ceiling, simply render it by mental ray sun system with mental ray. And then you can visualize this kind of objects. We're going to make this one later, not now. Okay, let's talk about 3D Studio Max interface and this software in detail. Basics in 3D Max. Let me simplify 3D Studio Max. What to do in 3D Max? Even other general 3D tools, what you can do? That's the question. First one, modeling. The term modeling, when we say the modeling in this semester, that's going to be geometric modeling to create objects. Secondly, rendering. In other words, to visualize your shape, your geometry, your design. Third one, to animate your scene, making animation. But actually, number 2, number 3, they are almost same. Series of animation, series of rendering, gonna be animation making. Even if you don't know what is FPS, there is the term FPS. Usually 30 FPS is kind of decent movie. Frame per second. In other words, 30 frames per 1 second in general animation or TV show or movie files. So just simply think about that. Your rendering scene, one single shot takes 1 hour, very high quality image. That is one single rendering. What if you want to make 10 seconds animation in the same quality? One render shot per 1 hour, but for 1 second, 30 FPS frame per second, so 30 hours per 1 second. So 10 seconds, 300 hours. So rendering, animation, they are equivalent each other, but there is a matter of computing performance and time. So series of rendering is making animation. In this semester, you're one of the lab exercises going to be this, making animation. Not that complicated. That's almost same. In other words, there are two most important things, modeling and visualization. Modeling is very difficult, very hard to do, and time consuming. I'm not talking about making sphere or box or plane. I'm talking about modification of geometry, what you want. Very complicated shape. Very hard to do, very time consuming. Rendering, too many things to take care of, but not that hard to do. It's easy. That is why you can generate photorealistic image just based on our 2-3 weeks learn study. Animation, hardware dependent. If we use back burner, you can render 30 times faster than before, because using back burner, all entire 30 computers will work for you through the network at the same time. That is network-based or cloud-based rendering. So we have that environment, but I realized that it's not working, because even if we have that environment, most of you came here and worked together. So it's not that meaningful. So anyway, hardware dependent. You need more CPUs, more RAM, memory, graphic card, so that you can get some reduced time. Okay, get back to modeling. Create 2D geometry and 3D objects. Import predefined 2D, 3D objects and manage them, modify them. In rendering, you have to take care of materials, take care of lights, even cameras, and amount of render options, so that you can get the high quality, your final image. Let me show you 3D Max use scenario for interior architecture. I told you before, what is UOD? What's UOD? Universe of discourse, your universe for your design in 3D Max. Very simplified, small universe. Define your UOD first. What's in your mind? If you don't know, roughly sketch it by freehand, so that you can determine, okay, I don't need a box, I need only single plane and a cube, cylinder, that's it. A teapot, something like that. You should determine what kind of objects, geometry you need. And then modeling by computer, 3D Max. Firstly, modeling universe. In other words, modeling environment, your environment first. Secondly, modeling your design elements, your thing. If you want to design a new teapot, you have to design environment, bottom plane first, and the sun or lights, and then define your teapot. In universe environment design, there are planes, walls, sky, outside view, modification, and so on. What are walls? When you are designing your studio work, you have to design walls. You have to design stairs, windows, doors, ceiling, bottom slab, and so on, because they are all building elements. You are working on that design, that building design. But what if you don't need to design such things? Your focus was just furniture. In that case, just single plane and another plane. That's it for one single shot. No need to define walls or windows and so on. Simplified, kind of fake environment. Your determination should be defined in that initial stage. And model your objects. 2D sketch, 3D modeling, and sometimes import or download your object and modify them. Rendering, material mapping, lights, camera, rendering scenes, and back and forth. If you need to get back, go back to modeling stage and do something, update something, and render it. Final image should be retouched by some 2D graphics tools such as Photoshop. Sometimes Photoshop edit takes much efficient and shorter time than rendering everything in 3D Max. It takes really longer time. I will show you some examples later. Photoshop is kind of world-best software, perfect software, so you have to know Photoshop very well. Okay, this is kind of use scenario. Today, even last week, we gonna deal with some mental sky and sun environment and some rendering features. Today we're going to use camera. Simply use camera. So this is some part of our location we are doing now. 3D Max uses scenario in inter-architecture design. This is kind of summary, another version of use scenario. Before modeling and rendering, defining UOD first. Your universe. You have to design your universe first. If your universe doesn't require design a building, you don't need to design a building. It makes your rendering or modeling very slow. Sometimes blue screen, stuck. You're going to get in trouble. So make everything simpler as much as you can do. So roughly design your universe by freehand, and here I list up. This UOD is not reflecting real world. It doesn't need to real. It could be fake, just surface. We will see that. We will, in the lab exercise hour, we're going to do that. Simply think about there is very high tide ocean, water. We can model it by its waving, moving. But actually, we don't need to do that because there are amount of additional features to make it fake. We're going to handle that today. Very powerful. Anyway, even if it's fake, that's okay. Final visualization image tells everything. And the 3D geometric modeling is very hard to do and very time consuming. You can reuse predefined objects, your design. And you have to use very well and high resolution image so that you can make your thing some fine grained. Model in 3D Max take shorter time to do in AutoCAD. Very simplified version and cleaned version you need. And some edge smooth using some modifiers or options. We're going to deal with that one today too. Some rendering basics I posted. You can refer to what are these. In actual lab exercise hours, we're going to review those aspects as well as some retouch in Photoshop. I told you before, Photoshop is the world's perfect software. Less is more. Just render close to final and retouch it, Photoshop, in shorter and efficient way. This is 3D Studio Max interface, Cartesian coordinate system in XYZ, workspace, steering wheel, and view cube. But you have to use hotkeys. I place very fundamental hotkeys here. For example, Alt-W, G to show, to hide grids, Q, W, E, R, H. They are very important. Selection, move, rotate, scale. H, select by name. Control A, select all. Space bar, lock toggle, and so on. M, material editor, F10, render setup. Shift Q to render. And amount of more hotkeys you can define. You can set up your own customized keys, but at least those keys should be you use. Just open this page for your information when you are using Max. That's my suggestion.